whether or not it's defective. So when all the pens are just mixed up, suppose we are having a box like this, and here good pens are also there and defective pens are also there. So just by looking at the pen, it's not possible to identify whether it's the good one or it's not the good one. So the pen that is 132, all the pen that is 132 plus 12, everything is just mixed up over here. Now the question says one pen is taken out at random. We are just taking out one pen from here. Determine the probability that the pen taken out is a good one. So we have to find the probability that we are taking out the good pen. Now probability of getting a good pen, we know we can find any probability just by the formula, that is number of favorable outcome by total number of outcome. So the formula which you have used in the previous class, before the previous class also, the formula which you have used, that is the same formula, that is number of favorable outcome by total number of outcome. Now once we will try to pick out the good pen from this box, from this basket, how many total pens are there? Defective is also there, not non-defective is also there. That means total pens are 132 plus 12, that is 4. This is 3 plus 1, 4. 144 total pens are there. What we want to take it out from there? We want to take it out the good pen. So we, how many favorable cases are there? 132 favorable cases are there. That is the favorable number of outcome, and total number of outcome is 144. So probability of getting a good pen will be just favorable outcome, that is good pen is the favorable one. So good pens are 132 only, divided by total number of outcome, that is 144, and this will give us the probability of taking out a good pen or probability of getting a good pen. So basically this is the formula which we are going to apply in each and every question, that number of favorable outcome by total number of outcome. Okay, once I'll be taking one tricky question or tougher question, then you will get to know it more well. Here this was very basic question, that like we are having this much of um, good pen, this much of defective pen, and everything is just getting mixed up. Now what is the probability of getting the good pen? If we have to find the probability of getting a defective pen, then the probability will be favorable outcome. So we will be writing how many defective pens are there. Probability of getting defective pen, if we have to find, let's say this one we don't have to find in this question, the red one, we just have to find the green one, that's what is written in the question. But if we have to do it, probability of getting a defective pen, that will be 12 defective pens are there out of 144. From where this concept of probability exactly came out? You have seen so many times, whenever we find the percentage, whenever we find the fractional marks or something, can you like, have you noticed that always teachers or everybody just give you marks? Suppose you are giving a class test, and in that class test it is of 20 marks, and you have scored, let's say, 18 marks. So we always write the marks like this: 18 out of 20. Have you seen this type of a structure in on your copy every time? Yes or no?
Yes, ma'am.
So this is how we are finding the probability also. Okay. This is how we are finding the probability. That is, what is the total number of outcome? What is the favorable outcome? Favorable outcome we are keeping in the numerator. Total outcome we are keeping in the denominator. So this is how we find the we write the fractional marks. This is how we find the probability, and this is how, just by doing multiplication of 100, we get the percentage of marks also. So these all the terms are just related with each other. Okay, let's move to the next question. One 32 by 144 we have got. You have to reduce this fraction in the lowest, you have to reduce it in lowest term. Okay, numerator and denominator, you have to do the cancellation. Now the next question says a lot of 20 bulb. Again the same question. There are a lot of 20 bulbs are there. Total 20 bulbs are there and 4 defective one are there. Okay, let me read the question properly. Whether this 20 is containing 4 or apart from 20 we are having 4 defective. So let me read the question. The question says a lot of 20 bulb contain 4 defective one. So total is 20. Among that only we are having 4 defective. Okay. One bulb is drawn at random from the lot. What is the probability that the ball is defective? So in this in this bucket, in this basket, we are having 20 bulbs. Okay. Total 20 bulbs. Among that only there are good bulbs, there are defective bulbs, but we don't know how many good bulbs are there, but we know that total 4 defective bulbs are there. Defective bulbs are 4. So definitely from here we will be able to find how many non-defective bulbs are there. If out of 24 is defective will be total minus 4, yes or no? If out of 20, 4 are defective bulb, the non-defective bulb will be 20 minus 4, right? That is 16 bulb will be there, which will be non-defective. Yes or no? Now the question says, what is the probability that this ball, we are taking a ball randomly from this slot, from this basket, and what's the probability that this bulb is defective? We have to find the probability that this bulb, whatever we are taking it out, is defective. Probability of getting defective. So now only we have discussed that probability formula is same. Whatever it was in the previous class, here also we are having the same formula. Then why we are learning it again? Because there are some tricky questions which we need to understand over here. Okay. So probability of getting defective bulb will be favorable outcome, that is 4, by total outcome, that is 20. Now the second part says, suppose the bulb drawn in is not defective and is not replaced. So let's say whatever bulb we are taking it out is not defective. That means a good bulb, non-defective bulb, we are taking it out. And it is not getting replaced. So we have picked one bulb from here, one bulb from here, and that is non-defective bulb. Now we are not going to replace this basket. So if total 20 bulb was there, we have taken it out. And now how many bulb will be there? How many remaining bulb will be there if we are taking it out and just keeping it aside? Anyone? If total 20 bulb was there and we are taking one bulb from there, that bulb was obviously non-defective. So how many remaining bulb will be there still in this basket?
19 divided by 20.
Exactly. Now we are having 19 bulb over here. Now what exactly we have to find over here? Now one bulb is drawn. Now one bulb is drawn at random from the rest. What is the probability that this bulb is not defective? We have to find the probability that this bulb is not defective. From this lot, 19 lot, we are taking out one bulb and the probability of getting not defective. So one not defective, we have taken it out. How many not defective we were having? 16. Here 16 not defective we were having, and out of 16, one already taken out. So can I say 15 non-defective bulbs are still there? Can I say? Are you
No.
getting it? Let me explain. So we are having a, let's say we are having a basket. Okay. In that basket, total 20 bulbs are there. 20 bulbs. Among that 20 bulbs, 4 defective bulbs are there, and 16, obviously the remaining 16 non-defective is there. That is the case, first case. Now from that basket, what we are doing, we are taking out one bulb, and that bulb is non-defective. So 4 defective was there, 16 non-defective was there. So if we are taking out one bulb and that is non-defective, total non-defective bulb will be 15 right now. Yes or no?
Yes.
Yeah. So total 15 non-defective bulb will be there, which is still there in the lot. Just let me share the screen and let me show you. So I am saying initially this was the case. Initially this was the case that 4 defective and 16 non-defective, total 20 bulbs. Now the case is one ball we have taken out and kept it aside. Now we are not going to replace the bag. We are not going to replace the bulb which we have taken it out. So now total is 19. But the case is whatever we have taken out, that was non-defective. So 15 non-defective is remaining, and 4 defective is still there. So number 2, the part 2 says, suppose the bulb drawn in part 1 is not defective. Just a moment. Is not defective and is not replaced. Now one bulb is drawn at random. Just a moment, I don't know what exactly started happening. At random from the rest probability that this bulb is not defective. This is what we have to find. Okay. So now we are having total 19 bulb, and among that, what is the probability that this bulb is not defective? That means how many remaining non-defective bulbs are there? 15. So can I say probability of getting non-defective bulb now will be 15 over 19. Total outcome, that is 19. Favorable outcome, that is 15. So can I say the probability will be 15 over 19? Are you getting it?
Yes.
Everyone, are you getting it?
Yes, ma'am.
Okay. Let's move to the next concept. So number 18 says a box contain 19 discs which are numbered 1 to 90. 19 discs are there which are numbered 1 to 90. If one disc is drawn at random from the box, find the probability that it bear a two-digit number. So if one disc we are taking out from the box, what is the probability that it probability of getting two-digit number? Total outcome 90. Favorable outcome two-digit number. That means two-digit number starts from two-digit number starts from 10, 11, 12, 13. Like from 10, two-digit number starts, right? If we are having 1, 2, 3, 4 till 90, then 1, 2, 3, 4, 5, 6, 7, 8, 9. Till 9 we are having one digit number, and after 9 you can see we are having two-digit number. After 9 only we are having two-digit number. So from 90, if we will exclude these 9 numbers, like 1, 2, 3, 4, 5, the remaining number will be two-digit number. Yes or no? Are
Yes.
you getting it? From 90, the total numbers, if we will exclude this one digit number, then whatever remaining we are having, those are two-digit number. So how many two-digit numbers we are having? 90 minus 9 will be 81. 81 two-digit numbers are there. Probability of getting two-digit number will be 81. Total 81 numbers are there. 81 such numbers are there which are two-digit number out of 90 numbers. Getting it? This will give us the probability of getting a two-digit number. You have to just reduce it to lowest fraction. Now, probability of getting a perfect square. So, what are the number which are perfect square, which lying in between 1 to 90? So, perfect square numbers are 1, then 2 square is 4, 3 square is 9, then 4 square is 16, then 5 square 25, 49, 8 square 10 square 100. In between 1 to 90, how many perfect square numbers are there? So 1, 4, 9, 16, 25, all are there, but 100 will not be there. Okay. So we can't take 100 because we are having disk. First disk is having number 1. Second disk is having number 2. Third disk is having number 3. Like this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 90. Till 90, we are having the numbers written on the disk. Okay, how many perfect square numbers are there? So these many perfect squares number has to be there. Okay, how many favorable cases are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 90. And that is the probability of getting perfect square. Is it clear? Is it clear?
Yeah.
Yes,
Yes.
ma'am.
Now probability of getting a number divisible by 5. probability of getting a number divisible by 5. What is the sample space? What's the meaning of sample space? Sample space means when I'm just going to toss a coin, head head can occur and tail can occur. This head and tail is called the sample space. When I'm going to pick one disk, how many total disks are there? What can be the, like, what is the total number of outcome? That is called sample space. Okay. So probability of getting a number divisible by 5. Total how many numbers are there? 90. How many numbers will be there in this 90 which will be divisible by 5? So let's write it. How many numbers will be there? Anyone? What will be the list of getting a number divisible by 5?
Total 18 numbers.
Yeah. So
Total 18.
total
18.
5. 5 is the number which is divisible by 5. So divisible by 5. Then we can 5 4 times 20, 5 5 times 25, 6 times 30, 7 times 35, 8 times 40, 9 times 45, 10 times 50. Still we can pick the number before, like, which is lying before 90. So we can go ahead and we can write more numbers. So 55 can be the another number, then 60, then 65, then 70, then 75, and then 90. Let's count it. How many total numbers are there? 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Perfect. It's 18. Total 18 numbers are there, which is in between 1 to 90, which can be divisible by 5. Okay. So 18 out of 90 numbers are there, which is divisible by 5. This is how we will be getting the probability. Let's do a few more questions from here. So the another question says a child has a die whose 6 faces shows the letter. So a child is having die. So first one is A, second one is B. Then we are having C. Then we are having D. Just a moment now. Then E, and then A. These are the alphabets which is written on the die. Okay, it's not a normal die where we are having 1 2 3 4 5 6. No, here it's the instruction or the condition is written clearly in the question that we a child is having a die and those dies are having this alphabets written on the die. Okay, now the die is thrown once. What is the probability of getting A? If the die is thrown once, then what's the probability of getting A? So let's see how many A's are there. What is the favorable number of outcome? So here we are having one A and here we are having one A. So favorable outcome is 2. From this 2, this is the favorable outcome. 4, 5, 6. Total 6 outcomes are there. So probability of getting A will be 2 over 6. Now the next part is asking what is the probability of getting D. Probability of getting D will be, how many D is there? Only one D is there. So one favorable outcome out of 6 total outcomes. This is how we'll be finding the probability. So basically, what's the difference between the previous class and this class? Because here exactly we are doing the same thing. One difference is there that we have to identify the likely event, those are equally likely, event those are not equally likely. So previous day I was explaining that what is equally likely and what is not equally likely. Let's recap those concepts for the understanding of other students also. So there was few questions. Yeah. So the very basic definition of probability we started from here, which says that here we are having, you are having the knowledge of number line where we were representing the numbers, the integers. Now when we move to the next class, we started representing the rational number, then the irrational number. Then we got to know, okay, this number line is the real number line where we can represent all the real numbers. So that was about number line. Here we are having probability line. Probability line starts from 0 and ends at 1. 0 is called the impossible event and 1 is called the sure event. So whenever we are having a box and that box is having just white balls, and if I am going to draw a pink ball from the box, that is impossible to happen, and that probability will be 0, which is impossible. Okay, so probability always lie in between 0 to 1. 0 means impossible event, which is not possible. You are having a bucket full of bananas and I am telling you just pick out one apple from there. So that is not possible and that's probability will be 0. Now one means sure event. When you are having a bucket full of bananas and I'm telling you to just pick out one banana from there. So that is sure and short. Whatever you are going to pick it out, that has to be banana. So that is called sure event. That's why we say 0 means impossible event, 1 means sure event, and whatever you will be calculating the probability, everything comes in between. Okay. Now after this, few very basic concept we have discussed, that probability equally likely and not equally likely. So equally likely means whenever we are tossing a coin, head can occur, tail can occur. So there are 50-50% chances are there that head will occur and 50% chances there that tail will occur. Both are having equal chances. That's called equally likely. Now if you are having a bucket again, there if I am saying 20 bananas are there and one apple is there, so probability of picking a banana and probability of picking an apple, is it same? So no, chances are not same. Chances of getting the banana and apple is not same because the basket or the bucket is having 20 bananas and only one apple. So there is a chance that whatever we will pick out, mostly we can get banana. Okay, because more bananas are there, so that is not equally likely. Equal chances are not there for banana and apple. On the basis of this concept, few fill in the blanks question we have done, that driver attempt to start a car, the car will start or not start, that is equally likely or not. Either the car will start or the car will not start. So that's equally likely or not equally likely. So obviously this is not equally likely because when the driver is attempting to start a car, we don't know what's the condition of the car. We don't know whether the car is having petrol or not, whether the car is the age old car or the brand new car. What exactly is the condition of the car? We are not aware of that. So we cannot say it is equally likely. Okay. Now the next, the one of the question we have discussed, a player attempt to shoot a basketball. So he or she will shoot or miss. Now it depends upon the preparation of the player, how much the player is like how much capable the player is and how much preparation the player has taken. So if the player is very like one of the best player who never miss any shot, then obviously more chances are there. Okay, so here also we cannot say it's equally likely whether he will shoot or miss. It is not equally likely because more chances, if the player is not prepared at all, then the more chances are there he will miss the shot. And if the player is fully prepared and is one of the best player, then the more chances are there that he will shoot. So 50-50% chance is not there and it's not equally likely. Now the next one, a trial is made to answer true false question. Since here a trial word is mentioned, and anybody like you, me, anyone just sitting and picking a question. So true false question, whether we will be marking it true, the answer is right or wrong. So 50% chances there that the answer is right, and obviously 50% chances there that the answer is wrong. So this one we can say yes, it's equally likely. Okay, so these are few concepts which was not there in the previous class, which is here, and these were the few concepts which we have discussed apart from the basic question which we are doing now, that what will be the favorable event, what will be the total number of outcome, that's it. Apart from that, one more thing was there, that whenever we find the probability, let's say we are just tossing a coin, so the outcome can be, or the sample space, again and again I'm saying sample space so that it, this word will get registered in your mind. Sample space means all the outcome, total number of outcome. Okay, all list of all the outcome is called sample space, that means collection of all the outcome. Okay, so when we are tossing a coin, the sample space will be head and tail. Either it can be head or it can be tail. Okay, so here probability of getting head is 1 by 2, probability of getting tail is also 1 by 2. From here only one concept came out, that probability of getting head plus probability of getting not head is 1. So not head means tail. Okay, so whenever we have to find probability of something, let's say if we know probability of getting head is 1 by 2, then probability of getting tail, without going and looking into the sample space, without using the formula, we can say probability of getting tail, it's just like 1 is the total, and from there we are subtracting whatever we know. So 1 minus 1 by 2. If you don't know what is tail, okay, directly you can find it with the help of probability of getting head, because total, we say that the total is 1, and from 1 if we will be subtracting head, then we will be left with the probability of getting tail. Okay, so these was the few concept. Suppose we are having a basket, and this basket is containing 20 green ball, uh, let's say 13 blue ball. So probability of getting green ball will be 20, that is 20 plus 13, that means 33. And probability of not getting green will be, not green will be 1 minus 20 by 33. Okay, and this not green means what extra is there, blue is there, so not green is also, not green can also be called as a blue ball. So with the help of green only you can find not green. Now what's the use of this not green? Not green means blue only, because there are only two different types of ball, green and blue. If something is not green, that has to be blue. Okay, so this is the second formula which we have discussed. Now probability always lie in between 0 to 1. I have shown you the probability line. 0 means impossible event, 1 means sure event. So these were the total everything which we have discussed till now. Okay, let's move to the next question. Now the next question says, suppose you drop a die at random on a rectangular region. We are having a rectangular region. Here we are dropping a die. Die means dice. Okay. What is the probability that it will land inside the circle? In this rectangular region, we are having the circle as well. Okay. And the measurement is given. This is 3 meter. This is 2 meter. Okay. And diameter of the circle is given as 1 meter. So it's asking, suppose you drop a die at random. We are dropping a die at random inside this rectangular region. But what is the probability that it will land inside the circle? If I want it to land inside the circular region, then favorable outcome will be this circular area. I want my die to be anywhere on this circle. Then what is the favorable outcome? This circular area. And what is the total outcome? Total outcome is this total rectangles area. Okay. So if we wanna place the die inside the circle, then favorable outcome is circle's area. Total outcome is total. Uh, total number of outcome will be total area. So probability that die will inside the circle. Till now you were dealing with the number of ball, number of digits, number of like how many odd numbers will be there, how many even numbers will be there, like numbers everywhere. We were dealing with the number, but here this is slightly different. Okay, if we are having a total rectangular region and there is a circle inside that, and if I am throwing a die and I want my die to be inside the circle, that means I want my die to be anywhere inside the area of the circle. Okay, so favorable outcome will be area of the circle. Total outcome will be area of this rectangle. So area of circle. We know the diameter of the circle is 1 meter. So radius will be 1 over 2 and area of the circle will be, that is pi. R is 1 by 2. That's a square. So area of circle, rectangle, that is the total area, total number of outcome. So area of circle is pi r square and area of rectangle is length into breadth. Length and breadth both are given. This is how we will be getting the probability that our dice will land inside the circle. Are you getting it, everyone?
Yes, yes.
Okay. Now the next one, a total 144 ball pen, of which 20 are defective and others are good. Noori will buy a pen if it is good, but will not buy if it is defective. The shopkeeper draw one pen at random and give it to her. What is the probability that she will buy it? She will buy it. That means she will buy only and only when the pen is not defective. Let me write the data over here. Okay, and let me write the like little bit of information which is given in the question itself, because you need to understand the question first and then only you need to solve uh, for the like ask probability. So let me write the given data in detail. So here we are having a lot. Okay, we have 144 ball pens are there total. of which 20 are defective. 20 defective we are having 20. So non-defective will be, let's find it just for the clarity, that out of it will be total minus 20. So 144 minus 20, that is 4, 2, 1. 124 non-defective ball pens are there. Noori will buy a pen if it is good, but will not buy if it is defective. Obviously, whenever we are going to buy any stuff, we want a fresh piece, right? And when we are buying a pen, every time I just write it on the paper and then only buy it. You also do the same. I'm talking about the general pen, not a packed one in a box, the very usual pen which we buy for daily use. So do you do the same thing? First you write it on the paper and check it whether everything is well or not, or you just buy it from the market? Yes, do let me know. Everyone, do you check it or you just buy it without even checking? If you are buying a packet of 12, 13, 14, I'm not talking about that. But if you are buying one or two pen, then what you do? You just check it, right?
Yes.
Okay. So she is also checking the pen and then she is buying. If the pen is good, then and only then she is buying. That means she is going to buy the pen if the pen is not defective. How many not defective favorable cases are there? Probability of getting not defective we have to find. But it is not written in the question clearly. In the question it is written that what is the probability that she will buy it. So obviously when the pen is good, when the pen is not defective, then only she will buy it. So probability of not defective only we will be finding when the question is asking about this part, the circled part. Okay. So not defective is 124, total pen is 144. If this will be the probability that she will buy the pen, and the probability she will not buy it, so the remaining defective pen, if it that will come out, that is the case when she will not buy the pen. Probability that she will not buy. This is how we will be finding the probability. Clearly, it is not written in the question which probability we have to find. But since yeah, but since the word is saying that she will only buy when the pen is good, she will not buy if the pen is defective, then we can use this concept to find the probability. Let's move to the next one. Refer to example number 13, complete the table. Event, sum of two die. Okay. So we are having a table over here. Before that, let me take the another question. We'll be just getting back to it, because here if I'll start drawing and plotting the table, that will just take the whole time. So I'll be taking this question, but before that, let's move to the next one. Okay, so the next question says, a person, Hanif, a game consists of tossing a 1 rupee coin 3 times. A game consists of tossing a 1 rupee coin 3 times. The person is tossing the coin 3 times. What will be the sample space? That is the main thing. Okay, let me read it ahead. And noting its outcome each time. Hanif win if all the tosses given the same result, 3 head or 3 tail, and loses otherwise. Calculate the probability that Hanif will lose the game. So you should know, when we are tossing a coin 2 times or 3 times, what will be the sample space, that you should know. And how we will how we will list down the sample space, what will be the total number of outcome. Let me show you. First time, let's say head came out, either head came out or tail came out. Okay. Now, if we are tossing the coin again after head, okay, I got it head, and again I'm tossing the coin. So the chances are either I will get head after head, or I will get tail after this head. Similarly, suppose first case has not been happened. I have landed on tail. So after tail, if I am going to toss the coin, then the chances are after tail I'll be getting head, or after tail I'll be getting tail. Is it clear so far to everyone? So
Yeah.
what are the possible total number of head can occur, head tail can occur, tail head can occur, tail tail can occur. How I am writing this sequence? I am writing it like this. If we are tossing a coin two times, then I am writing is head head, then head tail. Just I am making a tree, okay, or tail head, or tail tail. These are the all possibility which can occur. हेड के बाद हेड आ सकता है, हेड के बाद टेल आ सकता है, टेल के बाद हेड आ सकता है, और टेल के बाद टेल आ सकता है. These are the all possibility which can occur. Is it clear for two coin? Everyone, how we
Yes,
will be
ma'am.
making the tree? Is it clear? Let's move to the when we are next part, when we are going to toss a coin three times. So whenever we will be tossing a coin three times, first time head can occur or tail can occur. After this head, again branch will show head. After head can come out. After head, tail can come out. Similarly, after tail, head can come out. After tail can come out. Now again we are tossing the coin. Okay, even if we are tossing the all the coin parallelly, or we are tossing all the coin back to back, it's the same case. Okay, so now again after this head can come, and after this head, tail can come. Similarly, after this tail, head can come. After this tail can come. Okay, so each one will give two branches, and that is one head, one tail. Similarly, for the downward one, after head, head can come or tail can come. Similarly, after tail, head can come or tail can come. Now let's list down all the sample space. So what will be the sample space? Let's see it here. Head, head के बाद हेड आ सकता है और फिर से हेड आ सकता है. सो पहला हुआ पॉसिबल आउटकम हेड हेड हेड. सिमिलरली अब हेड के बाद हेड भी तो आ सकता है. सो लेट्स राइट इट हेड हेड टेल. सिमिलरली एक एक ब्रांच को पकड़ के लिखना है हमें. ठीक है, तो हेड के बाद टेल आ सकता है और टेल के बाद फिर हेड आ सकता है. लेट्स राइट इट. हेड के बाद टेल आ सकता है, टेल के बाद हेड आ सकता है. Similarly, head, tail, tail. Now, tail, head, head. Tail, head, head. Now, tail, head, tail, tail. Now, tail, tail, head. Now, tail, tail, tail. Can you see what are the total possible outcome when we are tossing three coins? How we will list it down just by making a tree? Are you able to get it?
Yes,
Everyone?
ma'am.
So this is how we will be listing down the sample space, that these are the total possible outcome which can occur. Now let me read the question. A game consists of tossing a coin 3 times. This is the three times case. Okay. And noting it outcome each time. Hanif win if all the tosses give the same result. Hanif will win the match if all the tosses is going to give the same result. So he will win when all are head-headed, or he will win if all are tail. Okay. Two favorable outcomes are there if he is going to win. Okay. Now what the question says, if all the tosses give the same result, he will win. That is 3 head, 3 tail. And he will lose otherwise. Otherwise, he will lose. So, except this head and tail, if any other outcome will come, then he is going to lose the game. Okay. Calculate the probability that Hanif will lose the game. So, he will lose the game when the outcomes are this, 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 and this. How many favorable outcomes are there so that he will lose the match? So 1, 2, 3, 4, 5, 6. 6 outcomes are there among 1, 2, 3, 4, 5, 6, 7, 8. Among 8 outcome, if six such outcomes are there, which he will get, if he will get, he will lose the match. So probability of losing is, probability that he will lose the match is 6 over 8. Is it clear to everyone? Is it clear?
Yes, ma'am. Yes,
And
ma'am.
probability of winning will be, two such cases are there which will make him win the match. So 2 out of 8. This is how we will be listing down when 2 coin, 3 coin, and even 4 coin are getting tossed. You should know what is the total number of outcome. Not only knowing the number of outcome, you should know the list so that you can write the probability according to the given condition. Okay. So this was the last question of today's. Um, Today I have taken this one as a last. We will be continuing the same topic. Few more questions are there. I will be checking whether those are doable or not. If those are doable, I will be giving those as a homework. And if you want to ask anything from here, please unmute yourself and ask. Please feel free to ask. I'll be more than happy to answer your doubts. No doubts?